Beyond our solar system, the universe reveals planets that exist in conditions far more extreme than anything found near Earth. These worlds are shaped by forces so intense that they push physics to its limits. With crushing gravity, violent atmospheres, and temperatures that swing from unimaginable heat to absolute cold, they show us how unforgiving planetary evolution can be. Some of the most extreme planets orbit their stars at dangerously close distances. A single year on these worlds can last only a few hours. One side of the planet remains permanently exposed to its star, glowing with molten heat, while the opposite side is locked in eternal darkness. The contrast between these two hemispheres is so severe that it creates winds moving at thousands of kilometers per hour, redistributing heat in a constant struggle for balance. On the hottest known planets, temperatures soar beyond 2000 degrees Celsius, hot enough to vaporize rock and metal. The surface does not remain solid for long. Instead, vast oceans of molten lava stretch across the planet, slowly circulating beneath a glowing sky. In these conditions, familiar weather disappears, replaced by clouds of vaporized minerals and rain composed of molten materials. Other planets exist at the opposite extreme, where cold dominates every aspect of their environment. Far from their stars, temperatures plunge so low that gases freeze and fall out of the atmosphere. The surface becomes buried beneath thick layers of ice, and any internal heat struggles to escape. Time on these frozen worlds moves slowly, shaped by darkness and silence. Some planets do not orbit stars at all. Known as rogue planets, they drift freely through the galaxy, untethered to any source of light or warmth. Their surfaces are locked in permanent night, and their temperatures approach absolute zero. Any remaining heat comes only from the slow decay of radioactive elements deep within their cores. Gravity presents another form of planetary extremity. Certain planets are so massive and dense that their gravitational pull is several times stronger than Earth's. On these worlds, movement would be exhausting, and even standing upright would place immense strain on the body. Mountains struggle to form, crushed flat by their own weight, while the atmosphere is held tightly against the surface. Some gas giants amplify this extremity through endless storms. Their atmospheres churn violently, with winds reaching thousands of kilometers per hour. Massive hurricanes swirl continuously, dwarfing Earth in size and lasting for centuries. Lightning flashes constantly, illuminating clouds made of exotic chemicals rather than water. On a few remarkable planets, weather behaves in ways that feel almost unreal. Temperatures are so high that metals like iron evaporate into the atmosphere, condense at higher altitudes, and fall back toward the surface as metallic rain. Entire atmospheric cycles are built around materials that, on Earth, remain solid and stable. Radiation also defines many extreme planets. Orbiting unstable stars, these worlds are bombarded by powerful stellar flares that strip away atmospheres and scorch surfaces. Any chance for long-term stability is erased repeatedly, leaving behind planets that are constantly reshaped by their stars' violent behavior. Some planets are stretched and deformed by intense tidal forces. As they orbit close to massive stars or companions, gravity pulls and compresses them repeatedly. This constant flexing generates heat, driving relentless volcanic activity and reshaping the surface over and over again. Perhaps the most surprising discoveries are planets that challenge current scientific models entirely. Some are far larger or denser than theory predicts, while others orbit stars in ways that should not be possible. Each new finding forces scientists to rethink how planets form and survive. These unexpected planets suggest that planetary systems are far more flexible than once believed. Worlds can migrate vast distances after forming, pulled inward or flung outward by gravitational interactions that reshape entire systems. What begins as an orderly arrangement can slowly evolve into chaos, producing planets in places they were never expected to exist. Some of these worlds appear to have survived events that should have destroyed them. Close encounters with stars, violent collisions, or near ejections from their systems leave visible scars in their atmospheres and orbits. Instead of breaking apart, these planets endure, reshaped but intact, offering clues about resilience on a cosmic scale. In other cases, planets seem to exist in temporary states. Their atmospheres are actively escaping into space, stretched into long streams by stellar radiation. Over millions of years, these planets may shrink, cool, or vanish entirely. What we observe is not a finished world, but a moment in an ongoing process of planetary loss and transformation. These discoveries also challenge the idea that planets are static objects. Many are dynamic, evolving constantly as their stars change over time. As stars grow brighter or more unstable, planets that were once temperate can become uninhabitable, while frozen worlds may briefly warm before conditions collapse again. The more extreme these planets appear, the clearer a pattern becomes. Stability is rare, and permanence is an illusion. Most planets exist in states of transition, shaped by forces that never truly rest. The universe favors motion, interaction, and change over long-term balance. Each newly discovered world expands the boundaries of what scientists must consider possible. Models are rewritten, assumptions discarded, and new questions emerge. Instead of narrowing our understanding, these extreme planets widen it, revealing a universe more complex and unpredictable than once imagined. Ultimately, these planets remind us that survival in the cosmos is not guaranteed. Worlds are born, altered, and sometimes erased by forces far beyond their control. In that context, Earth's long-term stability appears not just fortunate, but extraordinary. Even so, these extreme planets are not distant curiosities with no relevance to us. They help scientists understand the limits of atmospheres, gravity, and temperature, and reveal how small changes can turn a world hostile or habitable. By studying planets that failed to find balance, we learn why Earth succeeded. Every violent storm, crushing gravity well, and frozen surface deepens our understanding of how rare and delicate a life-supporting planet truly is.